Good day, folks. Welcome to my YouTube channel. Today I'm looking at the electric circuit graph question. This is the past question paper. Now it says in an experiment, learners use the circuit below to determine the internal resistance. So they use this type of circuit, which is a rheostat, and then they increase and decrease the resistance there, and then the battery has an EMF and an internal resistance there. It says the circuit consists the cell of EMF E and an internal resistance R. A voltmeter is placed across the variable resistor, which is set to a known resistor R. Right now, the equation used by the learners is this. So this equation, guys, will be given most of the time. You're not going to be required to derive that equation. It's quite tricky to do that. So we have a graph here of the results that are obtained. It was a inverse of the potential difference and the resistance. Now the inverse of the potential difference and the inverse of the resistance, they give the what? The direct proportionality. There's an increasing graph there. Now, if you look at this graph, guys, there's a direct proportionality and it's a linear graph. It has the gradient. We have to find the gradient there, right? Okay. Now, in 9.1.1, it says write down the mathematical relationship for the slope of the graph. Basically, this question, it wants the slope of the graph, right? So the slope of the graph, guys, here we know the gradient is the slope, which is the change in y over change in x, which is what will be our y there. It's going to be 1 over v. This is 1 over v, right? And divide by 1 over r, which is our x here, right? So this is going to be 1 over v, and then we change this division into a multiplication, and then we invert the 2, so it's going to be r over 1. And then that will be r over v. So our gradient, it can be sorry guys, it can be r and v. So we have to change that to something that is not here, which is something that is not in our variables, which is the dependent and independent. So we're going to change R into internal resistance and V into a EMF. So our gradient here is that. So that's what is asked here. The gradient here is, the answer here is R over EMF. That's the answer. So keep that in mind. That's our gradient there. Now it says use the information in the graph to calculate the EMF of the cell. So in this graph, the EMF of the cell, it's where your graph cuts in the y-axis. So you find the EMF there, but it's an inverse. So this point where it's an inverse of the EMF, right? Since it's 1 over V, so it's going to be 1 over EMF, right? So we want that value there. So 9.1.2, so we have to find that value there. So guys, if you're looking here, we have 0.5 to 1, so that means the difference between 0.5 and 1, it's 0.5. So how many lines are here? It's 10 lines there. So we'll say 0.5 divided by 10, it's going to be 0.05, which means each and every line here, it represents what? 0.05, which is, that's what I calculated there. I've taken this distance from here to here, and then I divided by 10 because the lines here, each lines are 10 of them. And then I'll get 0.05, which is 0.05. It's a line. Each line is represented by that. So now we check which line is this. It's 1, 2, 3. So I'll times by 3. So I'll get 0.15. So from here to here, it's 0.15. And then I plus there 0.5. which is going to be 0.65. So what it means here, guys, from 0.5 there to there, it's 0.65, but it's an inverse, right? It's an inverse. So this is simply means that the 1 over EMF is 0.65. But what are we looking for? The question, we're looking for an EMF. So what are we going to do? We're going to cross multiply. So we're going to have 0.65 0.65 times the EMF, and then 1 times 1, it's going to be 1, and then we divide by 0.65 both sides. We divide by 0.65 both sides. So if we post that in the calculator, we'll get the EMF is going to be this one, and this one will cancel. It's going to be 1,54 volts. That's the EMF, right? The EMF of the battery, right? Now let's go to the next question quickly. The last question here. It says the internal resistance of the circuit. If you're looking at the internal resistance here, the internal resistance of the circuit, we're looking for the internal resistance. You need to get the gradient of the graph first. The gradient of the graph first before we do that. So let me derive the equation where it comes from first. Okay, let me write here. Let me derive for you the equation and show you where it comes from, this equation of this graph, the one that we're given there. Guys, if you can see here, we are given 1 over V, that will be your Y. 1 over V is equal to your gradient here, as I've derived, is going to be that, which is going to be R over EMF. And then your X is going to be 1 over R. And then where your graph cuts, which is your C, it's going to be 1 over EMF. So this is going to be your Y equal, and this is going to be your M, and this is going to be your X, and this is going to be your C. So what are we looking for in this question now? We are looking for an internal resistance. So internal resistance is something that is in the gradient, right? So we're going to calculate the gradient. So calculating the gradient, we have to get 2 points, right? I'll get 2 points here, which is I'm going to take this point, which is 2. It's 2 and what? 2 is to what? It's 1, 2, 3, 4, 5, 6. So it's going to be 6 times 0.05. 6 times 0.05, it's going to be 6 times 0.05, it's going to be 0.3. So from here, since it's 1 here, from here to here, it's going to be 1.3, right? So the answer here is 0.3, and then we plus the 1, it's going to be 1.3, right? And then another point that I'm going to take that is easy there, it's going to be 0 is 2. This value here, it was 6.5, right? I'm going to take those 2 points, right? So I'm going to say here, I'm going to say the gradient, which is change in Y over change in X, is equal to R over E. Guys, I'm doing the last question, finding the internal resistance. So the change in Y over change in X, I will say 1.3 minus 6.5 divide by 2 minus 0 is equal to it's going to be the R that I want, and the EMF, it's 1.54. Where's the 1.54 I get from? This is that. So when you do the math here, this side, when you do that, but there's something wrong here. It tells us that the gradient is going to be, so let me double check the points. It's 2 and 1.3, right, which is fine. And here is 0 and no, not 6.5. That's the wrong part here. It's 0.65. 0.65. I can see my gradient is going to be wrong here. So it's 0.65. So I'm going to punch this side on the calculator. So I'm just going to put that in the calculator. It's 1.3 minus 0.65 divided by 2 minus 0. It's 0. It's 0.325 is equal to 1 over r 1/54, and then I cross multiply, and then my r is going to be that times 1.54. So the answer is going to be what? A half there. So the internal resistance that is asked in this question is 1.5. I hope that makes sense, guys. Cheers. Bye.